Hello, Honors Algebra 2 Trig students. This is our first video in Unit 8A. It's all about angles and the unit circle. Uh, you're used to seeing angles, especially in triangles. Um, what we're going to be working with this unit, often we're going to start angles with what's called an initial side and end it on the terminal side. Terminal meaning ending, initial meaning starting. On the coordinate plane, we generally start our angles on the positive x-axis. We call this the initial side of an angle. Then the angle opens up a certain amount. We're going to open it until it ends somewhere. We're going to call this the terminal side. That makes this angle that starts here and ends here have that initial side and that terminal side. It could have some sort of a measure to it. It could be like, say, 225 degrees, an angle that's bigger than 180. And our angles could have all types of measurements based on this initial and terminal side. Now, right now we're measuring this one, the first one in degrees. Often we measure angles in what's called radians. Uh, you're going to see radians way more often throughout your math career. Degrees existed because the Babylonians did their numeric system in base 60, where we do ours in base 10, and 60 squared is 360. However, if we're not going to choose an arbitrary number for how big something is, we could use radians. And what happens is 1 radian is how much of an angle you would need to have on the circle an arc length that is the radius long. So if this purple curved was like a string that was about the same length as this radius itself, that would make this angle here be 1 radian. And it's because this angular part in here would have an enclosed arc of 1 radius long. So we would be able to see that if you have 2 pi r being the circumference, then 2 pi radians should be the angles in a circle. Where a radian is the angle that it takes to be 1 radius of length. So for example, if you wanted 2 radians and this was a radius of 5, and say you had here being another radian as well, that would mean from here to here is 10. And that measuring system refers to how many radians as in how open this is. That's 2 radians open. Now we can convert back and forth from degrees to radians. What happens is that you have 2 pi radians being a full circle, which we know is 360 degrees. A degree symbol is kind of important here because 360 is not just some number, it has the unit of degrees on it. Well, if you wanted to see how much 1 radian is, you could divide by 2 pi on both sides. So you would get that 1 radian is 360 divided by 2 pi degrees. Or that 1 radian is 180 over pi degrees. So this is important to realize. Also, you could go a different direction with this, and you could divide by 360 on both sides. So that would give you pi over 180 of a radian is 1 degree. Now this comes because 2 pi is a full circle for radians, pi is a semicircle for radians. So if we looked here at 60 degrees, well, each degree is pi 1/80th of a radian. Well, we could reduce this fraction here of 60 pi over 180, divide by 60 in the numerator and denominator, so we get pi thirds radian. Well, likewise in this one here, we have 135. Each degree is pi 1/80ths of a radian. 135 and 180 both divide by 45. So here's 3 sets of 45, here's 4 sets of 45. So you have negative 3 pi fourths of a radian. So here we have 3 pi radians. Pi is 180 degrees, so we have 3 times 180 degrees. So this is 540 degrees. We have 5 pi ninths radians, so pi radians is 180 degrees. So this is negative 5 pi ninths. We could go ahead, we have 180 over 9, we could reduce that. 20 degrees, because every pi ninths of a radian is 20 degrees. It's a ninth of 180. So negative 5 times 20 is negative 100 degrees. You actually didn't need to put the radian indicator here. The default measurement is going to be in radians. However, if you're doing in degrees, you have to put the degree symbol. Now down here we said each angle on a coordinate plane is coterminal. Coterminal means ending together. Or ending at the same place. If we look up here, this angle of 225 had an initial side and at the x-axis and a terminal side being right here. Well, there's a lot of angles that end there. I could go this way and say, I'll take another circle. I could take another circle, and that angle in the red is a circle bigger than 225 degrees. That is coterminal because it's ending at the same place. Likewise, I could, instead of going in the positive direction, I could go in the negative direction. And this angle starts and ends in the same place. It is coterminal. This would be a negative 135-degree angle. Now, what's happening is that these coterminal angles are a full circle away from all other coterminal angles. There's a certain amount of circles there. So to get them, you can either add, well, you have to add a circle. So what would happen, for example, if you guys went up like a half pipe and you're skiing or snowboarding, if you go up the half pipe and you come back down the same direction you went up, you've gone an angle of 0. You have not rotated at all. But if you go up and you rotate 360, you're at the same spot that you started, the same way the person who went up and didn't rotate at all. So you could have been going up the half pipe and say, oh, here's the half pipe. I leave the ground and I'm going to come back down the exact same way. That is coterminal to going up, getting here, and here I'm going to make a little snowboarder. Here's a little snowboarder. Maybe it's you. We go up and we come down, the rotation was 0. We go up, you rotate 360. Well, you rotationally are in the same spot you were before. You come back down pointing the exact same way. Well, think about like the really good snowboarders. They go up. They could rotate 3 times. 1, 2, 3. That means they went 3 sets of 360, or what's called a 1080. Well, they came back, and their ending position looks the same as somebody who doesn't really know what they're doing, just came up and came down. I mean, part of that person, they didn't fall. But that would be coterminal to each other because they end at the same place. So we want here a positive and a negative coterminal angle for each. So, well, if I have 330 degrees, I just add a circle, which is 360 degrees, to get 690 degrees. To get a negative angle, I could have also gone the other direction in a circle. So subtract 360 from 330 and get negative 30 degrees. Those are both going to start and end in the same place. Well, from here to here, I could add a circle, and a circle in radians is 2 pi radians. So I could take pi sevenths radians and add 14 pi sevenths, which is 15 pi sevenths. I could subtract 2 pi, which is subtracting 14 pi sevenths, because I'm subtracting a circle, and get negative 13 pi sevenths. Those both would be coterminal because they're just a circle away from the original. Now, each angle in the coordinate plane has a reference angle that we use to help to understand it better. Now, what happens is, say if you have this angle here. This angle is 3 pi fourths. Overall, we prefer, and here I should draw the terminal side for it, we like to think about our angles within the first quadrant between 0 and 90 degrees. These are going to relate this 3/4 pi radians angle and the angle right here. This angle right here is what it takes to get back to pi, or back to the x-axis. It's pi fourths. So we have a reference angle of pi fourths because it gets us back to the x-axis in the shortest way possible. All reference angles are either going to show up looking like this. Notice how all of these are going back to the x-axis. It's kind of looking like a bow tie. Or in a taller version, they all come down to bow ties and TIE fighters. They all come back to the x-axis with a 90-degree angle. So if we look for the reference angle for 560 degrees, first of all, 560 degrees is 360 degrees plus 200 degrees. So that ends us back in this quadrant. Well, the reference angle will get us back to the x-axis. Well, 360 plus this here being another 200. That means more than 180. We have 20 degrees more than 180 here. So our reference angle is 20 degrees. Now in number 8, we're going negative. That means we're going into the clockwise direction. Negative 2 pi thirds is 2 pi thirds this way. And I probably could draw this just a little better. I could probably draw that this is 2/3 of the semicircle. Here's 1/3, here's 2/3. Well, that leaves us pi thirds left over to get back to the x-axis. Reference angles will always be positive, and they will always bring us back to the x-axis. Oh, 47 pi 11ths. All right. Well, 47 pi 11ths. We have 44 pi 11ths plus 3 pi 11ths. Every pi of an angle is a semicircle. So here's 11 pi 11ths. That's a semicircle. Here's 22 pi 11ths. Here's 33 pi 11ths. Here's 44 pi 11ths. And after you get to 44 pi 11ths, you have 3 pi 11ths more. Well, 5.5 pi 11ths is halfway, so I'm less than halfway, somewhere around here. This reference angle is going to be 3 pi 11ths, because what would take to go back to the x-axis. Pi fifths is a fifth of a semicircle, something like this. That's way too much. That's like a fourth of a semicircle. So I probably could just do a little bit less. It's a fifth of a semicircle. Well, it takes a fifth of a semicircle to get back, so it is its own reference angle, and sometimes that will happen.